Bismillahirrahmanirrahim. You are watching Advanced Level Chemistry with Mudassir Mehboob. Today we are going to discuss oxidation state and rule for assigning oxidation state. Just stay with me for 3 minutes. You will be able to assign oxidation state to any element or to any atom in a molecule or a compound. Okay, so first of all, what is oxidation state? Oxidation state is actually the apparent charge on an atom or element in a compound or in a molecule. Okay, so it is the charge on an atom, or we can say or an element in a compound or molecule. For example, we have sodium chloride. So the according to the rule, sodium chloride, the oxidation state of sodium chloride is as a whole 0. Okay, so inside this sodium, it has positive charge and this chlorine has negative charge. So we have assigned positive 1 plus 1 charge to sodium, and we have assigned minus 1 charge to chloride. So that is the apparent charge on an element in a compound is actually termed as the oxidation state. So the oxidation state of sodium is +1 and chloride ion is -1. Now look at the sodium calcium chloride. The overall as a whole, calcium chloride is neutral. It has no charge. So inside this calcium chloride, we know that calcium that is belong to the group 2A elements, and group 2A elements always has the oxidation state of +2. So that is, so to counterbalance these +2 charge, we have two chloride, one is -1 and the other one is also -1. So +2 and -2, they cancel over one another, and +2 cancel over -2, and we got as a whole the oxidation state of calcium chloride as a whole 0. Now, so in a calcium chloride, the apparent charge that we have assigned to the calcium, that is +2. So +2 is the oxidation state of the calcium. Now look at the water. Water has this structure. Look at. Okay, so hydrogen has +1 oxidation state, and this hydrogen that also has +1 oxidation state. So the both have +2 oxidation state. So I give -2 oxidation state to the oxygen ion, so as to balance the overall charge and is to 0. Okay, so that is somewhat regarding the oxidation state. Now we will discuss the rule for assigning the oxidation state, that what are the rules that we should know to assign the oxidation state to an element in a compound. Okay, so the first one, that is, every element in its elemental form, or we can say in a free state, has the 0 oxidation state. For example, this is the sodium. So sodium is alone. So it is present alone, so charge on it is 0. We have calcium, and this calcium is alone, so charge on it is 0. We have iron, so iron has enough, alone is present in elemental form, so its oxidation state is 0. Or we can say when we have molecules, for example like H2, like O2, like N2. So these are all, they are present in a free state. So in a free state, these all have the oxidation state 0. Okay. Okay, so the oxidation state for the hydrogen, keep in mind, is always B plus 1, will always be plus 1. But there is only one exception for metal hydride. Its oxidation state is minus 1. For example, as we have seen in H2O, hydrogen oxide, that its oxidation state is plus 1. But in metal hydride, these are the metal hydride, for example sodium hydride or calcium hydride. So in these things, the oxidation state of hydrogen is minus 1. Look at the another we have we have another rule, and this rule is regarding oxygen, that the oxidation state for oxygen is always minus 2. But in OF2, it has the oxidation state of plus 2, and in peroxide it has the oxidation state of minus 1, and in superoxide it has the oxidation state of minus 1 over 2. Okay, so that is all. Another we have another rule, and that rule we have already I have already described to you, that as a whole molecule or a compound has a 0 oxidation state. You have done we have done with sodium chloride. As a whole, it has 0 oxidation state. We have talked about the H2O, it has also 0 oxidation state. Okay. Another rule, and that is for an ionic species. If we have an ionic species, so charge on that ionic species will be equal to what? Will be equal to the sum of the oxidation state of the atoms or element in that species. For example, we have for example we have sulfate ion, we have SO4 ion, SO4 minus 2. So SO4 minus 2, this ion. So here the oxidation state of oxygen is, these are the normal oxide, so the oxidation state for oxygen is minus 2. So there are four oxygen, so as a whole it has minus 8, and sulfur has the oxidation state of plus 6. So plus 6 minus 8, so the result is minus 2. So sulfate ion, this is the sulfate ion, which is an ionic species. So charge on it will be equal to the sum of the oxidation state of the atoms or elements present in that ionic species. Now last rule, and it is a very much important rule, and it is that the group 1A element has the oxidation state of plus 1 always. Group 2A element has the oxidation state of plus 2 always. Group 1A elements mean lithium, sodium, potassium, rubidium, cesium, francium. Okay, and group 2A elements the calcium, magnesium, beryllium, strontium, barium, radium. These are the group 2 elements, so they has the oxidation state +2 always. And group 3 element, boron, aluminium, gallium, indium, thallium, they have the oxidation state of +4. And group 7a elements, which are actually the halogen, they have the oxidation state of -1 in usual cases. But in some other cases, in the interhalogen compounds, when halogen form or react with another halogen to form a compound, so in the interhalogen compounds, they may have the oxidation state of sometime +1, +3, or +5, or even +7. Okay, so that is all about regarding the rules for assigning the oxidation state. Just give me 2 minutes. I am solving a few examples for you, so you will be able to assign oxidation state to each and every element in a molecule or in a compound. Okay, so so I have potassium permanganate, KMnO4. You know that potassium that has the +1 oxidation state, and we also know it. And look at, we have the oxygen. So oxygen has the oxidation state -2. So for oxygen, it has the oxidation state of -8. So what oxidation state I can give to the manganese to neutralize all this, so as a whole KMnO4 become 0. So what oxidation state I can give to the Mn? Just think on it. If we give it +7 oxidation state, so +7 +1 +8 -8 +8 and -8, they will cancel out one another, and as a whole we have 0 oxidation state. So manganese that has the oxidation state +7 here, I am talking about here. Okay, another example, that is H2O. So we know that the hydrogen has the oxidation state +1 always. So +1 +1. What oxidation state I can give to the oxygen, so as a whole, to neutralize water, so that I assign oxidation state of -2 to the oxygen. So oxygen has the oxidation state of -2. So that is. Now look at the potassium. Look at the potassium permanganate. Look at, you know that the potassium has the oxidation state of +1. So there are two potassium, so it has the oxidation state of +2. Oxygen, you know that oxygen has the oxidation state of -27, so -14. So what oxidation state I can give to the chromium? Okay, so so what should I do here? I should give here it plus 12 to both of the chromium, so as to neutralize potassium dichromate. So potassium dichromate is, so for one chromium the oxidation state is, that is +6. Okay, and if we talked about the CRO, chromium oxide. So in the CRO oxygen has the oxidation state of -2, and chromium has the oxidation state of +2. So in the chromium oxide, the oxidation state of chromium then will be +2. Okay, so now look at the hydrogen peroxide. Okay, the the structure of the hydrogen peroxide is like this one. Okay, you know, here is peroxide linkage. When oxygen is linked with another oxygen atom, so it does not affect the oxidation state of this oxygen, neither this oxygen. So that is the reason we can write the oxidation state of the hydrogen is +1 always, and here is +1 always. So what oxidation state we can give to the oxygen? So we give oxidation state here to -1 and also to -1. So that is the reason in hydrogen peroxide the oxidation state of oxygen is -1, and that is why -1, because oxygen is linked with another oxygen atom. Okay, look at keep this thing in mind. If we have this carbon. Look at we have this carbon. So this carbon is bonded to 4 hydrogen. So okay, so +1 +1 +1 and +1. So the oxidation state of carbon is -4. Okay, here the oxidation state is -4. I am talking about for the carbon. Now look at here, what will be the oxidation state of carbon here? Okay, here what will be the, so this carbon is linked with, this is +1, hydrogen is always +1 and +1. Okay, and this carbon, or the oxidation state of this carbon when linked with this carbon atom is not affected. So the oxidation state of this carbon is here -3, because it is linked with the 3 hydrogen, and when it linked with this carbon, so the oxidation state will not be affected. So we can write the oxidation state for carbon in ethane is -3. Okay, so that is all about the lecture on the oxidation state and a rule for assigning oxidation state. I hope you will got all the points. Okay, thank you very much for watching, and do not forget to subscribe. Thank you.